To a 250 milliliter beaker, add 10 milliliters of the provided oil, which in this case is olive oil. Then add 10 milliliters of ethyl alcohol, also known as ethanol. Finally, add 15 milliliters of a 20% sodium hydroxide solution to the beaker. Note that he is wearing gloves because this is a corrosive solution, and safety first. Then he'll place the beaker on a hot plate to heat the mixture, being sure to stir it occasionally. Also note that the temperature is set to a medium setting, so it is not too hot. Once the solution is heated, the alcohol will start to boil. At this point, he'll begin stirring vigorously until the reaction has taken place. Notice that if you don't stir, the solution will start to pop, so it's important to keep stirring. As the reaction proceeds, soap will start to precipitate. Continue stirring to get all of the alcohol out of the mixture. It's good. You can see the precipitating on the walls. When you think that the reaction is complete, remove the beaker from the heat. Add 40 milliliters of 20% sodium chloride solution and mix thoroughly. The salt solution will help precipitate the soap. Next, use a vacuum filtration setup to collect the soap. This is a vacuum filtration setup. It consists of an Erlenmeyer flask, a Buchner funnel, which has small holes in the top and flows down to the bottom, a rubber stopper between the funnel and the Erlenmeyer flask, to trap any air that might escape. There's a hose connected to the Erlenmeyer flask, which will then connect to a vacuum line in the hood. This yellow nozzle here. Also labeled on these knobs on the outside of the hood. Be sure to add wave paper to the funnel so that no solid can get through. Did you turn it?
Not yet.
Spray the funnel and the funnel paper with DI water to make sure that it sticks onto the funnel while the vacuum is turned on. Then pour your soap solution into the vacuum filtration setup to separate the liquid from the solid. You can see the liquid coming down here and the solid forming. You can also rinse your beaker with DI water to get the remainder of the solid out. Once your soap is all dry, you can take it out of the filter and put it onto a paper towel. Make a note of any observations that you might notice about the soap. Then test with pH paper to find out what the pH of your soap is. Make a little soap solution using DI water and you can test for the pH. This is litmus paper, and the color that the paper turns once you put it in the solution will tell you the pH of that solution. This is the color of the paper after Jared dipped it in his solution. And you can see that it closely corresponds to a pH of about
13 or 14.
Yeah, between 13 and 14.
Very basic.
Yes. Then wash the filter funnel in your flask and put them back where they came from. Now make a soap solution containing half a spoonful of your soap and 100 milliliters of deionized water. You'll also make these solutions for a store-bought soap, Ivory soap, as well as the all detergent. Once the undissolved particles have settled, you can pour the clear solution into a clean beaker or flask. Then, in a test tube, you will place 5 milliliters of your soap solution. You'll do the same for the Ivory soap, the all detergent, and then there will be a test tube of just water. Nice. Then you will test the pH of each with pH paper. For the Ivory soap, you can see that we've already tested the pH.
It appears to fall within the range of 7. Our sample appears to fall within the range of 8. The sample of the all detergent seems to be around 9 to 10. And as our control, the water sample, of course, comes in at neutral, or 6.
Then you'll add about 10 drops of the cooking oil to each test tube soap solution and shake vigorously. This is the Ivory soap.
Let's do the rest.
Next is the soap that we just made. Next is the all detergent. And finally, the water. You can compare each of the solutions by seeing which tube has the largest oil droplets remaining. The ivory, the soap that we made, the all detergent, and the water. Next, you will pour the solution out of each test tube and then fill each test tube with tap water and empty the tube twice.
This time.
Mm-hmm. After rinsing with tap water, you can now compare the tubes to see which are free of oil droplets. This is the water tube. You can see many oil droplets still in there. This is the all detergent. In 3 large test tubes, place 5 milliliters of each soap solution. Also 5 milliliters of the all detergent. Then add 2 milliliters of 1% calcium chloride solution to each tube and shake. Record your observations. This is the synthesized soap with the calcium chloride solution added. You can see solid particles forming in the test tube. This is the all detergent with the calcium chloride solution added. This is the ivory soap with the calcium chloride solution added. After observing what happened, we poured out the contents and rinsed the test tubes as we previously did. You can see that all test tubes are free and clear after rinsing with water. We'll then repeat this process by now adding 2 milliliters of 1% sodium chloride solution to the detergent samples. This is our synthesized soap. This is the all detergent. And finally, the ivory soap. Next, pour out the contents and we will rinse the test tubes again. You can see that after rinsing, all tubes are clear. We'll then repeat the process once more, this time adding 2 milliliters of 1% iron chloride solution to each test tube. This is the synthesized soap. This is the all detergent. And finally, the ivory soap.
Oh.
Here's a comparison of all three. You can see, you may not be able to see very clearly, but in the ivory soap there are solid particles. And in the other two there don't appear to be any. After rinsing with tap water, all tubes appear to be clear.